Alright, so here we are in lesson 15, equations of graphs of proportional relationships involving fractions. So, just more of what we've been doing. Just now we have tables and we have some graphs, and we're going to use that to write our equations. So, first of all, I know the spacing looks a little different on mine than it is on yours, but that's okay, it's the same question. Alright, it says that Sam's mother has entered a 10K race. Sam and his family want to show their support of their mother, but they need to figure out where they should go along the race course. They also need to determine how long it will take her to run so that they will know when to meet her at the finish line. Previously, his mother ran a 5K race with a time of 1.5 hours. Assume Sam's mother ran the same rate as the previous race in order to complete the chart. It says create a table that will show how far Sam's mother has to run after each half hour from the start of the race, and then graph it on the graph to the right. So first we need to find our constant, which we know is y over x, right? So we know that our time here is going to be our x, and our distance is going to be our y. So we know that she ran a 5K in 1.5 hours. So if we're going to calculate our k, we have 5 over 3 halves. So we're going to multiply both by 2. So we get 10 over 3, which is 3 1/3. And this would be kilometers per hour, so kph. So in the table, we're going to do every hour. So 1, 2, 3, 4, 5, 6. So in 1 hour, she runs 3 1/3 kilometers, so fill that in. After 2 hours, that means she would run 6 2/3 kilometers. After 3 hours, she would run 10. After 4, she would run 13 1/3, and then we'll do one more. After 5 hours, she would run 16 2/3 kilometers. So now we need to plot the points on the graph. So our first one is going to be at 1 hour. It was 3 1/3, which is going to be somewhere around here in between 2 and 4. After 2 hours, it was 6 2/3, so just above the 6 then. After 3 hours, it was 10. And then that's the last one we'll be able to fit on there, so we'll connect our points and draw an arrow that shows that it goes on forever. Alright, so our equation for this then would be y equals 3 1/3 x. So part A says, what are some specific things you notice about the graph? So if we remember back to what we had to notice before, we noticed that it's a straight line, and it goes through the origin. Alright, so that's the first thing. And then if you flip over to the next page in your packet, it says, what is the connection between the table and the graph? And we know that they both have a constant, so that means they are both proportional. And then the last thing, part C says, what does the ordered pair 2, 6 2/3 represent in the context? So the 2 is x, which is time, so we would say in 2 hours, she ran 6 2/3 kilometers. Alright, so that's all for that one. So you can go ahead and flip over to your back page, which has the example about gourmet cooking. So it says, after taking a cooking class, you decide to try out your new cooking skills by preparing a meal for your family. You have chosen a recipe that uses gourmet mushrooms as the main ingredient. Using the graph below, complete the table of values and answer the following questions. So we know that weight is going to be x and cost will be y, and that'll help us out here. So the first point that we need to fill in is at 1, and the cost for 1 pound would be $8. And then if we're looking at the cost of $16, it means we're looking over here at the y-axis then. And for $16, it would be 2 pounds. Alright. So The first question asks, is this relationship proportional? And then how do you know from examining the graph? So you have to read it. It doesn't say anything about finding K or writing an equation. Just let's look at the graph. And we know it is proportional based off of what we see. So we can say yes, because it's a straight line. And goes through the origin. All right. Now part E says, what is the unit rate for cost per pound? So now, this is where we have to find our K. So our K is y over x. So let's try to pick a nicer one here, maybe like the 8 over 1. So our K is 8. So that means that it costs $8 per pound. The next question says to write an equation. So we know it's y equals 8x because our K equals 8. Part G says, what ordered pair represents the unit rate and what does it mean? So remember, unit rate would be 1 comma r. And we saw this question on our last test. So our r is 8, so it would be 1 comma 8. And that means that every 1 pound costs $8. Okay. H says, what does the ordered pair 216 mean in the context of this problem? So same thing, x is pounds, so it'd be that 2 pounds costs $16. Alright, part I says, if you could spend $10 on mushrooms, how many pounds could you buy? So we're going to use our equation. So if they gave us money, money is y, so we're going to plug in 10 for y, and this equals 8x. So that means we have to divide by 8 on both sides. So 5/4 equals x, but it's money, right? So first let's convert it to a mixed number. So this would be 1 1/4, and this is a lot easier to write than in dollars. This would be $1.25. Okay. Then one more here, part J, what would be the cost of 30 pounds of mushrooms? So now we have pounds, which is x, so it would be y equals 8 times 30. And that would be 240, so it would cost $240. Right? When I just realized from the last part that I have the wrong label. It's not $1.25. They were asking how many pounds, so this would be 1.25 pounds or 1 1/4 pound. Alright, so that's all we're going to do. We'll do some more practice in class tomorrow, but that's it for this video.